After understanding the process of manufacturing oil tanks, it finally becomes clear why these tanks are considered one of the greatest inventions in the petroleum field. Even a steel plate the size of a dish requires advanced processing technology to handle the internal and external pressure differences to avoid explosion issues. The process details are impressive. Here we are in a large tank factory at the first step of manufacturing an oil storage tank. Workers start by operating a CNC cutting machine, which precisely cuts the steel plate along its edge in a circular shape. In just a few moments, the necessary material for the tank is formed. Next, it is transported forward, where the steel plate is aligned with the central hole and pressed firmly until it is fully secured. The press machine is then activated, and the roller on the right starts to turn. Under the hydraulic transmission of the machine, the metal undergoes plastic deformation quickly, and the steel plate visibly bends inward. Next, final horizontal calibration is done until the edge dimensions meet the specified requirements, and then it moves to the next stage. Here workers are rolling the tank body using alloy steel about 1 centimeter thick as the main material, significantly increasing the tank's hardness. Next, the welding machine is placed on the rails, and when the switch is turned on, it slowly moves forward along the preset track, welding as it goes. The entire process takes about 2 to 3 minutes, and the steel plate becomes a refined product. After this, the weld seams are polished to remove residual iron filings on the surface, forming the segmented tank body. The next stage is overall welding, where 3 groups of tank bodies are aligned at a horizontal angle. From the inside view, the edges are very tidy with no excess gaps, proving the factory's meticulous attention to detail in tank manufacturing, something worthy of being learned by many smaller countries. After completing the welding of the 2 internal groups, workers clean up the scattered smelting sand on the ground for subsequent use. Now, look at this large pipe, which seems incomplete, so a steel plate is installed on one side. First, one end is inserted and then stretched out forcefully so that the steel plate fully adheres to the tank body. Then the connection is firmly welded, completing one side of the tank. We then move to the external treatment process. First, the required points are measured with a long ruler and marked. A circular pattern is drawn using tools centered on the mark. The machine then cuts with high precision according to the marks. Although this process looks difficult, it is indeed complex, as it requires cutting the circle very precisely and avoiding uneven edges, since it's not possible to fix individual sections. After forming the circular hole, the valve well, also known as the operation well, is installed, where the level gauge, used for detecting flow and velocity, is placed. Additionally, there are other holes for installing pressure gauges, oil inlet and outlet holes, and ventilation holes. With temperature changes, the oil vapor inside the tank can cause volatilization, increasing the tank pressure. The ventilation holes help to relieve this pressure, reducing the risk of tank explosion and leakage. Therefore, manufacturing this large iron tank is not an easy task. The next and most important step is non-destructive testing. Workers spray paint on the welded areas, then use inspection tools to spray a liquid on the welding points again to check for visible gaps and potential defects. This step can only be performed by an experienced master. After the non-destructive testing is completed, workers apply fiberglass to the valve well and cover it with a resin solution, brushing the fiberglass surface repeatedly. Although fiberglass is highly hazardous, its advantages are notable. It increases crack resistance, hardness, and overall durability of the tank. Next, a spray gun is activated to apply a dense layer of fiberglass to the tank's surface, which might make everyone itch just by looking at it. Subsequently, a brush is used again to apply the resin solution to the tank multiple times. Fully protected workers indicate that this task is not easy, since these materials cannot be disposed of casually. Then a heater is used to bake the tank at 40 degrees for an hour. Now, let's talk about the importance of fiberglass. Those who have handled this material know it is brittle, but when combined with resin, it becomes very hard, forming a material called reinforced glass, whose hardness can reach 80 to 100 megapascals, reducing the probability of tank expansion. With the pressure gauge installed, the oil tank is now formed. The final step is factory inspection, mainly checking the FRP coating thickness, which must be greater than 3.2 mm according to industry standards. Now the oil tank is ready. Did you know this tank can hold tens of thousands of liters of gasoline?